In this video, we will learn about decomposition reactions. So, decomposition reactions are the reverse of combination reactions. In the combination reactions, we know that two substances combine to form a product. In the decomposition reaction, one substance decomposes to give us products, two or more than two products. Okay, those reactions in which a single substance breaks up to give two or more than two simpler substances is called decomposition reaction. An example of decomposition, generally we can write decomposition reaction in this way, but it can also be like anything. A decomposes to C plus D plus E, for example. Okay, so thus decomposition reactions are just the opposite of combination reactions. These reactions can be brought about by heat, light, or electricity. Why do we need heat, light, and electricity for these reactions to happen? Because we will need to break the bonds. For example, if you want any decomposition reaction to happen, you will have to break these bonds, initial bonds. Okay, without breaking the initial bonds, the decomposition reaction will not happen. Okay, so to break the initial bonds, we need energy, either heat or light or electricity, but we need energy. So the old bonds are broken, and then we get the product. In the combination reactions, sometimes combination reaction happens without giving any energy. Why? Because at that time we don't need to break bonds in the beginning, just new bonds are formed, so the energy releases. Okay, then now we will see some activities which will help us understand the decomposition reaction. First, to demonstrate decomposition of ferrous sulfate by heating. So the sulfate of iron, we will see how that decomposes. How can we conduct an activity so that we understand the decomposition of ferrous sulfate, that means sulfate of iron. What we will do, take 5 gram of ferrous sulfate in a test tube, okay, in a hard dry glass boiling tube. Then we will heat it. What we will observe, the color of the test tube will change. The change in color has changed. The change in color signifies that the change in color, color has turned, and also a smell comes out. So the change in color and a characteristic smell represents that ferrous sulfate has decomposed into something. Okay, now we will see what it decomposes to. It decomposes to ferrous sulfate, decomposed to ferric oxide and sulfur dioxide, and also sulfur trioxide. There will be traces of sulfur dioxide gas, sulfur trioxide gas, and but it decomposed to ferric oxide. Okay, so what we observe, ferrous sulfate decomposes on heating. We had to give heat in the beginning. We had to break the initial bonds. In this reaction, single reactant, that was ferrous sulfate, breaks up into smaller sub. That is, first ferrous sulfate has water with it. First, the water leaves when we heat it, so there will be water vapors, and then the ferrous sulfate will decompose. So first, when we heat it, water leaves. As you can see here, water is now separated. Okay, on further heating this one, what we get, ferrous sulfate further decomposes to ferric oxide and also sulfur dioxide and sulfur trioxide. And the brown colored ferric oxide and pungent smell gases. Pungent smell is due to sulfur dioxide and sulfur, these gases which are released on the decomposition of ferrous sulfate. Okay, we get ferric oxide and these two gases, and the smell is because of these two gases. Now, coming to another activity which will also help us to understand decomposition by heating. Now we will take thermal decomposition of lead nitrate. Similarly, we will take lead nitrate in a test tube and also heat this one. Procedure, take a hard glass boiling tube and put 5 gram of lead nitrate. Hold the boiling glass with the tongs, so that we don't burn ourselves as well. We will use the tongs. So on the test tube, heat the test tube over the flame carefully. What we will observe, brown fumes are evolved. These fumes are of nitrogen dioxide, because lead nitrate, when it decomposes to lead oxide and nitrogen dioxide. Fumes are because of this gas, nitrogen dioxide. So lead nitrate decomposed to lead oxide, nitrogen dioxide, and also oxygen. Okay, so in this case we will also see, what we will observe, brown gas. When we will observe the brown gas, we know that lead nitrate has decomposed to lead oxide. Okay, some other examples of decomposition by thermal decomposition, that means when we have to give heat in the beginning, that is called thermal decomposition, decomposition by heat. So these are the examples of thermal decomposition. Decomposition of potassium chlorate into KCl and O2, decomposition of potassium nitrate into KNO2 and O2, then decomposition of sodium bicarbonate in sodium carbonate and H2 and CO2. Similarly, decomposition of ammonium dichromate, all of these, decomposition of calcium carbonate, decomposition of hydrogen peroxide. So these six examples are of thermal decomposition. Remember, we have to give heat in all of these cases, otherwise the decomposition will not happen without giving heat. Okay. Now, coming to next decomposition, how can we perform electrolytic decomposition? That means we don't directly give heat, but what we give? Electricity. By using electricity, we decompose. By using electricity, a substance can be decomposed. Okay? Decomposition of a substance by the agency of an electric current is called electrolytic decomposition. So we are not directly supplying heat. We are using electricity to break the initial bonds. How can we do that? We'll understand with the help of an example. Activity 3. Aim. This time we have to use electrodes for the decomposition. Procedure. What we will do? We will take a plastic mug, for example, a big plastic mug, and we will use two electrodes. What are electrodes? Simply the electrodes are some metals connected to a battery. As you can see here, this one and this one. These two are electrodes, okay? Electrodes, use two electrodes, insert carbon electrode. As you can see, carbon electrodes in these two rubber stoppers, okay? Then what we will do, fill the mug with water. Fill the mug with water such that the electrodes are fully immersed in water. Now the electrodes are immersed in water. Add few drops of dilute sulfuric acid. Why? Because water is not that much conducting solution. We need a conducting solution. To make water conducting, we add few drops of acid. In this case, we are using dilute sulfuric acid, okay, so that it becomes a good conductor of electricity. Then take two graduated glass tubes and fit those glass tubes on the electrodes. As you can see, this is a glass tube, and we fit this glass tube onto the electrode. Okay, connect the two electrodes to a 6-volt battery. Then we connect them to a 6-volt battery, positive and negative, and then switch on the current. What will we observe? What will happen to these carbon electrodes? Graphite rod means carbon electrode. Graphite is carbon. What will happen? Observations. After some time, bubbles of gas appear at the both electrodes. That means something is happening. These bubbles replace water in the graduated tubes. That means in these two tubes, the water will be replaced by bubbles in these two tubes. Okay? And once the test tubes are filled with respective glasses, remove them carefully. After that, once the process is complete, we will remove them carefully. The volume of these gases is in the ratio of 1:2. We will see that in one of the test tube, the volume, and the other test tube, the volume will be in the ratio of 1:2, okay, of the gases. Test the gases by bringing, now we will have to see what gases these are, what gases were evolved. Test the gases by bringing a glowing splinter of wood close to them, okay? When the glowing splinter is brought over the mouth of the tube, which was placed over the cathode, there are two electrodes, cathode and anode, okay? One is cathode, and one is anode. When we bring the splinter close to cathode, the gas burns with a pop sound. Which gas burns with a pop sound? Hydrogen. So we know by pop sound that this gas is hydrogen. So we know that when we use carbon electrodes in water, acidic water, and then connect it to battery, what happens? Hydrogen gas is released. Where can hydrogen gas come from? Obviously, hydrogen gas cannot come from carbon. You might be thinking that we used carbon electron. How can hydrogen come from carbon? Hydrogen didn't come from carbon. Hydrogen came from water. Okay, because we are using water as a solution. Okay, then when the splinter is now brought in contact with anode, the other electrode, what happens? The splinter relights. That means combustion happens. And which gas supports combustion? That gas is oxygen. So we know oxygen is also released. So we can confirm that water has decomposed into hydrogen and oxygen. Okay, the chemical equation of the reaction shows that the number of hydrogen molecules produced is twice the number of oxygen molecules. Because of the reaction, when water decomposes, it produces 2 moles of hydrogen and 1 mole of oxygen. As temperature and pressure are same for both gas, therefore the hydrogen gas produced has twice the volume of oxygen, as we said. Okay, so this was an example of electrolytic decomposition. How can we use electricity to decompose water into hydrogen and oxygen? Okay, then we can also use light, and that decomposition in which we use light is called photochemical decomposition. Decomposition reactions may also be brought about by the agency of light by using photons. Such a reaction is called decomposition reaction. So, in the first case, we used heat directly. In the second case, we used electricity. Now, in the third case, we are using light. In all of the three cases, we are using energy in one or other forms. Okay, so the first case, in this case, we used energy in the form of heat. In the electrolytic case, we used energy in the form of electricity. In the third case, now we are using energy in the form of light. So, in all of the cases, you will need energy to decompose a substance. Okay? Now, let's see how photochemical decomposition happens when we just provide it light. Take 2 grams sulfur chloride in china dish. We took silver chloride. Take 2 grams silver chloride in a china dish. We took the silver chloride. Place the china dish in sunlight, open sunlight. What we'll observe? We observe that white colored crystals of silver chloride turn gray in sunlight. When those crystals will turn gray, we know that silver chloride has decomposed into something. Then, what we also observe, this is due to the photochemical decomposition of silver, because AgCl decomposed to silver and chlorine. Okay, silver bromide also gets decomposed in the same manner. So instead of silver chloride, if we had used silver bromide, it will also get decomposed into silver and bromine. Okay, so in this case, we can confirm that light also decomposes compounds. The above reactions are used in black and white photography, these two reactions. Okay, I hope this topic is clear to you.